Hello friends, my name is Hifivecode from hifivecode.com. First of all, thank you for joining me in this video today. In this video, we will be seeing an introduction to the Identity and Access Management System and how Keycloak fits into this technology. I'll go through in brief about the benefits of having an IAM system in front of the application, then the classical example of using a database for storing user credentials. Then we will be seeing some comparison between an OpenID Connect and SAML. After that, we'll try to understand the need of an authorization server with some examples as discussed before. We'll go through the login flow with and without an IAM to understand better and see for ourselves what are the real benefits of having it. Then finally we'll come to the conclusion of it. Identity and Access Management System mainly revolves around the two standard protocols, OpenID Connect, in short OIDC, and SAML, Security Assertion Markup Language. Before going in detail in these two protocols, let's us understand the very first question and try to answer it. What is an IAM system or Identity and Access Management System, and do we really need one for our application? Identity and Access Management System or an authorization server is simply a piece of software running in a secure environment or a private infrastructure whose main task is to assure an identity of a logged in person and to grant him access to a protected resources based on their access rights. This is not the formal definition of an IAM system, but to make it understandable more better, I have used it. We will also try to understand the same definition by having a very common public bus transportation example. I will try to correlate this public bus transportation example with the likes of Identity and Access Management System mechanisms. So whenever we want to use the service of a bus transportation, the first thing that we need to do is to buy a proper ticket for that bus. And once we buy the ticket, we as soon as we enter the bus, the ticket checker will try to verify the bought ticket. The first thing he does is he verifies the name on the ticket against the identity card that we present. So basically here what he does is checking the identity of a person and making sure that the right person is standing or is present in the bus. Then only after verifying this information, he goes to the next step and then he tries to verify the other attributes present in the ticket, such as date, time, the cost of the ticket, etc. By verifying this information, what he is trying to do is to check whether the ticket is valid or not. That is, your access right to use the ticket. So in a nutshell, these are the very two main tasks of any Identity and Access Management System, that is to authenticate a user and then authorize the same user before providing any access to a protected resources. Between authentication and authorization, in my opinion, I think authentication is very common, as most of us, we use it on daily basis whenever we visit a website and log in over there, for example, Facebook or Google. So when we enter our username and password in the form and clicks the submit button, we are exactly performing the authentication against the web application that we are using. And also to mention that authentication always follows a registration process. So any web application out there in the internet, it first has to go through the registration process of a user, and then only the user can authenticate on their web application. So once the user has done the registration process successfully, then the user can enter his username and password on their web application, and the web application then will show the correct user information based on their credentials. On the other hand, authorization is more of a background process or check after successful authentication. If the authentication step fails, then there's no need of doing any authorization for that user. In this thing, we can conclude that authorization always follows when the authentication step is successful of a given user. So I would say this would be the short introduction that I wanted to give on identity and access management system, and I think at this level it is enough to have some brief introduction about it. So now let's jump to the next question of what we have posted before, that do we really need an identity and access management system in front of our applications, or we can still use the traditional way of having a database integrated to our applications. So this slide is splitted into two parts. On the left hand side we see a login flow with the traditional database system, and on the right hand side we see the same login flow, but at this time we have an IAM system in place between the applications and the database. We'll start from the left hand side. Let's imagine there is a company named XYZ, and in the domain of this company there are a lot of applications running, and I have illustrated those applications like application 1 up to application N, and each of these applications will be having a mapped database corresponding to only that application. So application 1 will be connected to database 1, 2 to database 2, and application 3 to database 3, and so on. So let's see from the user's perspective and also from the development point of view that when we want to have such a system, what will be the drawbacks that we will be facing afterwards, and also like how it will be difficult afterwards to manage this. So let's imagine a user who is in the domain of this company XYZ want to access one of this application. So let's say application 1, he wants to authenticate against it. So the first step for that user will be to register himself in the scope of this company domain name. But in this case, because we have a scenario where each application has its own database, so this application must have some registration process which will be then saving that user information in this database. So let's for now imagine that user want to access application 1. So somewhere the component of application 1 will be registration. He goes to the registration page, he fills his entire information, his username and credentials, and then it will be saved in the database 1. Next time he has to come, whenever he wants to use application 1, he has to provide the same credentials and he has the access to his information. Now the same user within the scope of the company XYZ want to use different application, but because now the different application, let's say application 3, doesn't know that user at all, because the database of that application is entirely different than the database 3, and the same user was registered in database 1. So here application 3 should also then provide a component, a registration component, where the same user will again fill up the form, fill up his credentials, and go through the registration process. The information is saved in the database 3, and then only he can again in the next step or the next time can authenticate against the application 3, and he can then use the information. But imagine this is just 2 applications we talked about. If there are tons of applications, the work over here, the workload will be like creating the registration step for, or the component for each and every applications, then maintaining the database of the same user multiple times, And also from the user's perspective, he will be going through the registration process in every application. He will be filling the registration form in application 1, providing his username and password. He has to do the same thing in application 2, 3, and all the applications that he wants to access. The best case for him will be to use the same username and password throughout the applications, but this is really not recommended, because you lose the password of one application, all the other applications will be compromised. And the other case, which would be the worst case for the user, would be like to use different username and passwords all over the scope of this company XYZ. So if there are 10 applications, he will be using 10 different passwords. Imagine that the user will have to remember all his passwords. So in this case, other applications will not be compromised, but there will be a memory load on the user or a pressure that he has to remember all the passwords, which is kind of difficult for some people, but maybe some people can still remember it. Let us also see, like, if we restructure this architecture, will it solve the problem, like by not using the IAM system and still going with this somehow with the database and application integration. So upfront, I can think of two possibilities that we can do to illustrate the problem and to find or to come to a solution would be like to integrate all the applications till n to a single database. That would be one first solution. And the second solution would be that each application in the scope of the company XYZ has its own database, and whenever the user registers from any of the application, so the user information will be saved in that database, and then it should be replicated in all the databases within the scope of the company XYZ. I know that this is not the best solution or even a very proper solution, but just for the sake of argument, we are trying to restructure this architecture to see whether we can still have a working solution. I would personally never go with the first approach, that is to connect all my applications to the same database, because different applications are meant for different purposes. And as the complexities of the application will increase, it will be very, very difficult to also manage the database models and the structures and schemas. And on top of this, we will be having a single point of failure. That is, if one database crashes, we will be having all the applications that would suffer. In the diagram here, we are seeing just these 3 applications and up to n. Imagine in the real case scenario, when there are like real case problems, real case complexities, and when the number of application increases, having a single database for all the applications would surely be a no-go. So I will personally rule out the first approach from the picture. Now let's take the second option, that is that we will replicate the user information within all the databases that we have in the scope of company XYZ. As we already discussed before, so in the second case, when the user registers in the first application, the user information will be stored in the database 1, and during the same registration process, internally it will be replicated throughout all the databases in the scope or in the infrastructure. Now imagine a case where a user, the same user, is now updating his information in application 1. Whenever he does that, again the database will start the connection, will update that information, and as the background process, it will also update the same user information throughout the databases in the infrastructure. And apart from this infrastructure problem, there is also a security problem that each of the application in the scope of this company is connected directly to the database, and that also implies that the user information and this could be a high risk of user information theft or credential theft. So with all the hard work, and let's say manually we give more security precaution on this system, it will work on paper, but it will not be a very smooth user journey. Like from the user's perspective who will be using this application, it would be not a very friendly one. The users will end up having tons of usernames and passwords. Now let's see what role does IAM plays in these situations, and can it really solve the problem that we saw on the left hand side. And we'll switch on to the right hand side, and to compare fairly we will take the same example like what we did on the left hand side without an IAM system. So let's see this diagram on the right hand side. As you can see in this setup, we have the same company XYZ and we have the same number of applications, but in this system we have an additional entity called as IAM system. And as we already discussed before, that Keycloak is one of the implementation of an IAM system. And on the right hand extreme right, we have data sources where the user can come from. It can be either a database that is connected to an IAM system, an LDAP server, or any other external identity provider which supports OpenID or SAML protocols. And the tagline that I've used is like one user, one password for all applications. In order to make this setup work, the IAM system will first register each of the applications, and it will generate for each application specific metadata information, which we will then feed it to the applications. And this is how the application will be integrated to the IAM system on the left hand side. On the right hand side, the data sources or the user source is tightly connected to the IAM system with configurations, passwords, etc. So once we have this setup in place and a user, again from the scope of this company, wants to access one of the application in the infrastructure, he goes to the application and he requests to access a protected resources. So the user at this point will be redirected from his browser to the login page of the IAM system. Then the IAM system will ask the user to feed in the username and password that he used in the registration process. Yes, in this setup also the user has to go through the registration process because that is the fundamental of any authentication. So once the IAM system gets the username and password, it will check against the corresponding user source, and once it is confirmed, it will tell the application that the user is an identified and authorized user, and the user can be shown or can be granted the data that he is requesting for. In very brief, this is also the flow of how an authentication and authorization works in an IAM system. So what now if the same user now wants to access different application? So again, he will go to that application, let's say application 3, and he will request for the protected resources, and this time also he will see the same login page. So we will not be having different login implementations or registration implementations throughout the scope of this company XYZ if all the applications are connected to this IAM system. The user in application 3 will then feed the same username and password. The IAM system will check from the same corresponding user source as it checked before for that user, and then it will send the signal back to application 3 that the user is a legitimate user and the resources can be shared with the user. And if we carefully analyze, all the user sources are connected to the IAM system. So when the user feeds the username and credentials, applications does not receive any credential information directly. So it is the IAM system which just says in the form of token that user is good or not. But all the credential stuff is still happening inside the secure infrastructure between an authorization server and the persistent storage or LDAP server. Also to mention, when I say that an IAM system will send a signal to the application whether the user is a legitimate or not, it is actually like in OpenID Connect we say it as an authentication flow. In this authentication code flow, what exactly happens is like the user's browser will redirect the user to the login page of the IAM system, where the user is requested to feed in username and password. Once the user gives the right username and password, it actually checks and verifies against the user source, corresponding user source, and once it is successful, then the IAM system will generate a code and will send it to the application. The application will then make a post request back to the IAM system for the requesting the access token. Now this is also a verification step from the IAM system, because the application 1 has to send back the same code which the IAM system generated in the previous call. Only if those two codes matches, then only the IAM system will send back to the application the access token, which is also the final call to the application. The user can use this access token to get access to the protected resources within the scope of his access rights. Once all the call is finished, which also means that when the user successfully logs into one application, and because it is connected to the same IAM system, he doesn't have to go to another application and make a login call again. Once he tries to go into the private page of the other applications, he will find himself already logged in. This is also called as single sign-on. And to give an example, let's take of Google. So when you logged in to the Gmail, you will find that in the same browser session, you don't have to log in for your Drive or your calendar or other applications provided by Google. That simply means that, let's say the application 1 is Gmail, application 2 is Drive, application 3 is calendar. So what you did is you logged into your Gmail account or your Gmail application, and Google has their own IAM system running on the back, and other applications now looking into the IAM system knows that this user already has a session, and so it's okay to make the user get into the logged in page. And same will happen with the calendar application or any other application that is still connected to the same IAM system. The process that we discussed right now is also called as authentication code flow, and it is part of the OpenID Connect OIDC protocol. This brings us to the next topic, which is the two protocols that we left behind, namely OpenID Connect and SAML. We will not get into the details of these two protocols as they are well-known protocols and there is a well-structured documentation. I have left the link in the description below. So if any one of you are interested in knowing more about these two protocols, please visit the documentation website. So I'll give a brief introduction on the two topics, and then we will just see the high-level comparison between the two. Basically, these are the two ways that any IAM implementation must follow, and these protocols describes various structures, defines parameters, how the data will how the data exchange will take place between the two systems, and it in very detail defines in and outs of an identity and access management system. And also for the identity and access management, it must abide to the rules and protocol standards set by the documentation. Not doing so will cause unnecessary security breaches or loopholes, and will lead to many vulnerabilities in the software. Out of the two protocols, OIDC has gained more popularity over SAML during the last years, simply because OIDC uses HTTP channel to send lightweight JSON data or tokens for authentication, whereas on the other hand, SAML also uses the HTTP channel for communication between the two systems, but it sends the heavy XML to share assertions, and this is how the SAML authentication works, through the sending of these XML files. In the upcoming video in this channel, we will be seeing the examples or the tutorials mostly based on the OIDC, but also we will have very few examples on SAML, just to see that how SAML also works with the authentication and with Keycloak. So now let's get into the comparison between the two protocols, SAML and OpenID Connect. So I'll just go through this slide very briefly, and it is straightforward, so you can also take down directly from the slide. So SAML was born before OIDC in the year 2001. It was first introduced as SAML 1.0, and OpenID was first introduced in 2006, and later in 2014 it was combined with OAuth 2.0 to form OpenID Connect. So such in a nutshell, it was like OpenID was just for the authentication part, and other company or other firm, OAuth, was doing the authorization, and in 2014 they combined together to produce a single package that can authenticate and authorize at the same time, and hence it is called as now as OpenID Connect. SAML protocol, as I said, is based on XML data, whereas OIDC is JSON based. They use JSON Web Token for generating ID token, and sometimes they will also use the JWT for access token, but it is not necessary. It could be any random string for the access token. Here the SAML could be initiated by the service provider, or it can be initiated by the identity provider, but OIDC is always initiated by the service provider. SAML has a well-structured protocol standard of single sign-out. That means if one of the application logs out of the session, all the other applications connected to the IAM will also log out. So the user has to log in again if it visits other application. Whereas OIDC does not give clear picture on the logout mechanisms, and hence it does not have any single sign-out mechanism. So any implementation would have their own idea if there is one. SAML mainly works on trusting the certificates and signatures that it presents during the transfer of the assertions, while OIDC works directly by calling the endpoints like authorization and token endpoints over secure HTTPS connection, and it generates token for the connected applications. SAML is a protocol to enable SSO for mostly enterprise applications, whereas OIDC is also a protocol to enable single sign-on mainly for consumer applications. So this brings us to the last part of this video, and I will shortly summarize what we have gone through in this video. So we have seen the high-level definition of an authorization server. Then we had these two questions posted, that what is an IAM system and why do we need an IAM system, and I hope I give enough justification to answer these two questions. Then we saw lastly the comparison between a SAML and OpenID Connect on a very high level. And yeah, I have one more thing for you guys, that if you need to play with a Keycloak Playground, I have a real Keycloak hosted on this URL. So if you need your own realm, just shout out to me, and somehow we'll get connected, and I will pass you the credentials to log into the Keycloak, and you can integrate your own application with this Keycloak. With this, I will conclude this video here. In the next video, we will be looking on one of the implementation of SAML and OpenID Connect protocols called Keycloak. And also henceforth the whole video series will be based on Keycloak, and we will learn more and more examples in Keycloak. Till then, stay tuned, stay blessed, and don't forget to like this video and subscribe to my channel. Thank you guys. Thank you all.